Welcome, everyone. This is the 9th virtual Bevy meetup, and I'm super excited to be here again. This is now we are basically over 12 months of doing these meetups, and that's makes me very happy. I'm happy to see everyone here, and we were planning to have 3 presentations today, so I just want to clarify that confusing bit because I was advertising that the whole time, but due to personal reasons, we will have to wait for Marco's presentation until next time. It's just moved, it's not canceled, so I'm still excited to hear him in the next meetup. Okay, let's go quickly through our regular intro slides. We will have only 2 speakers today. Still, the format is pretty much the same, 15 to 20 minutes each, 5-minute Q&A. If there's more questions, we will save them up for a panel conversation at the end with everyone. Everything is recorded, live streamed, and will be released in individual videos later. So if you miss anything, that's no problem. I know this is a permutating through all time zones. We will have one example of that today as well, from morning to evening. So there's probably more convenient times for some people to watch this later. The code of conduct, be kind, be respectful, be curious. I encourage everyone to ask questions in our live Q&A. Find the link in the description. I will share it in the comments section as well. And if there's anything that gives you concerns, feel free to reach out to me, and we will look into that. Who am I? I'm Stefan. I'm using Rust since 2017. I've worked in the games industry for 18 years. You may know me for my open source projects, LiveAsk and GitUI. I recently founded the company Rust Unit, which is sponsoring this meetup. And if you are curious what we are doing, check out rustunit.com. And yeah, this is the QR code that leads you to the live Q&A platform. Please just hang around there, vote the questions up and down that you feel that are most interesting to you, and obviously ask questions as well. And now, without much further ado, let me get our first speaker of tonight up on stage. Give a big hand to Hennadii, or alias Shatur.
Hi, everyone.
Welcome. So let me give you your slides and have the stage for you. Thanks for being here.
Okay, so today we will be going to talk about replication in Bevy. A little bit about me. My real name is Hennadii, and you may know me in Discord as Shatur and on Mastodon as well. I work in at 45IQ as senior software developer, and it's not a game dev company, unfortunately. We develop tools that analyze hardware for vulnerabilities, but we use Rust. In my free time, I work on a live simulation game with a working title Project Harmonia. And I also maintain Bevy Replicon and Bevy enhanced input crates that I use for this game. So today my talk will be dedicated to authoritative replication. We won't touch deterministic replication. Authoritative replication is when you exchange states, and deterministic replication, and it's where you exchange inputs and rely on determinism to keep the state in sync. Authoritative is just much more common because determinism is quite hard to guarantee. Everything in this talk will be related to client-server architecture, and we won't touch peer-to-peer architecture. It's because I'm personally a big fan of this decentralization, but peer-to-peer is not very common for game development, mainly because it requires more bandwidth, it's have more issues with NAT and firewall, and it also requires implementing hard consensus models. While with client-server architecture, the server is just always the source of truth. We will also touch client-side prediction, but only briefly because of short time period. And we also won't touch transports. It's the way bytes are actually transferred over the network. So in Bevy, you have several huge ecosystem. And of course, we have several networking crates to transfer bytes over the network. Example of such crates are on the screen. And I want to show you a quick example of how this API looks like. You usually have a message, which is an enum, and you just serialize it using Hennadii and send it to a client resource. On server side, when you receive, you iterate over connected clients and read bytes and just pass it into Hennadii again to get your enum and match the data. All these libraries have an API like this. But if you used Unreal Engine or recent versions of Godot, it's not the API you expect, because usually you have a much more higher level API, where you can just mark things for replication and it just works. And you can also call functions over the network. It's called RPC, which stands for Remote Procedure Calls. And I wanted to bring something like this to Bevy. When I started developing the crate, the ecosystem wasn't that robust. We didn't have Lightyear, and I found Naya, another networking crate, quite hard to work with. So I decided to implement my own. Originally, it was part of my game, but after some time, I decided to make it into a crate. So what it provides? It automates replication. It provides networked events and triggers. And it's also abstracts the game logic. It allows you to have single player, dedicated server, listen server, and with using the same game logic. It also doesn't have any I/O because, we already have plenty of messaging libraries. So I figured out that it would be better to just hook it into Replicon and support them. And it's also have extensive architecture. I provide a lot of API to implement high-level abstractions. Originally, the crate wasn't abstracted from I/O. It was using ReNet. But after some time, I figured out that it's better to support multiple transports. And over the year, the library changed quite a lot. So let's talk about how it's implemented, actually. For some reason, animations on my slide doesn't work well. Okay, let me quickly display the whole slide. Okay, how to replicate the world? Simple. Basically, on both server and client, you want to decide which components you want to replicate, and then you need to decide which entities you want to replicate. Then on server, you just iterate or listen for server's entity spawn, despawns, components insertion, changes, removals, and resources. Bevy provides built-in mechanism for this, so nothing special is needed. And so we just utilized it. We also, in Replicon, we also don't listen for spawns separately. It's actually considered as insertions with zero insertions, basically, just for optimization purposes. And right now, we don't replicate resources. That's because Bevy have plans to migrate from resources to singleton entities. I saw a PR from Alice for this, but we are not there yet. So just waiting for the decision. Okay, and on client, you just receive the message, deserialize it, map server entities to client entities, and apply changes. Mapping process is important because when you receive changes, you need to know to which entities you want to apply them. So when you first encounter an entity, you create an entity on client and have a special map that maps server entities to client entities and vice versa. Okay, let's talk about the tick rate. For some reason, animations on my slides aren't working properly. Interesting. Okay, tick rate. It's you don't want to send changes every frame. It would be expensive for bandwidth and would tank the performance. So we have special Replicon tick resource that tracks a separate tick from Bevy's tick. And when this tick is incremented, the replication runs. And we have a special system that already increments the tick every time it runs. And it's configurable via server plugin. As you can see, in this example, I just disable this tick incrementation, and this way you can just schedule this system into a fixed update, for example, and have a fixed tick rate. By default, it runs up to 30 times per second. So now we need to register components we want to replicate. Here's how it's done in Replicon. You can just call up.replicate and then put your components in here. Some components may contain an entity. And I mentioned previously that for replication, we need to map entities. And since component can also contain entities inside, we also need to map the internals of such components. But we already have a built-in trait for it. So we just utilize that and have a special method called replicate mapped, which accepts a component with map entities implemented on it. This way, entities inside it will be implemented automatically. But sometimes you want to customize the serialization. And this is why we provide replicate with. It's a special method that allows you to register a component with custom serialization and deserialization. This is quite useful when you want to apply things like compression, or you want to quantize values, things like this. And another option is to register a group of components. It's also quite useful. For example, you may want to replicate transform only for players and keep the rest of the world without replicating transforms. This way you can call replicate group. It's similar to how queries work in Bevy. For example, in this example, we have player and transform. And if these two components are present on an entity, only then they will be replicated. This way you can also customize how specialized serialization for groups. For example, maybe for players, you want to replicate both translation and rotation. And for non-player objects, you may don't care for rotation. For example, if you replicate a ball, you may don't care about its rotation. This way, you can specialize serialization by implementing a special trait. After that, we need to mark entities for replication. It's also quite easy. You just insert this replicated component, and that's it. The entity will be replicated. I previously mentioned that we don't replicate everything because, again, it would be quite expensive, and client probably already have the necessary meshes it wants to display. So how to deal with such components? The answer is simple. Bevy recently introduced required components, which is just awesome tool for it. In this example, I create a player and assign mesh as a required component for it. Then I can just, as you can see, I inserted replicated in here because I want all players to be replicated. So I just mark it as required component, and all players will be automatically replicated. And then on insertion, I just create a special trigger, and I just listen for player additions or insertions, and initialize the correct mesh. Because I know, so for example, in my game, all players have specific mesh. So I know the exact mesh I want to initialize. That's quite convenient. If you have multiple meshes, you might have an enum, or you can transfer the path to the asset you want to load, things like this, and load proper asset in here. Okay, so moving next. Now, how to actually send messages, replication over the network? The thing is, messaging crates provide us with 3 channels: reliable, unordered, and unreliable. And when messages are transferred over the network, they are usually split by MTU. It's a maximum transaction unit. For Ethernet, it's usually 1,500 bytes. So the messages are split into packets, and the message is considered received only if all its packets are received. That's the way how messaging crate works. So how are we doing it internally in Replicon? Naive assumption would be that we can just use reliable channel because we don't want our updates to be missed, right? But it's not that simple. Let's take a look at the next slide. Here is the problem. If any packet is dropped, it gets resent with the same data. The issue with that is that when you do replication, you don't care about old values. Usually only interested in the recent one. Let's take a look at this example. On first tick, we have position X, and we receive it. We receive it. On the next tick, we might have different position, and we missed it. Packet didn't arrive. And on the next tick, we have a new position. And what will happen is that the backend will try to resend the position from tick 2 and a new position from tick 3. But we don't no longer care about the position that we had on tick 2. And this causes the problem. We just waste bandwidth for things we don't need. So we need some way to customize that reliability. How can we do this? Possible solution would be to just use unreliable channel and implement custom unreliability on top of it. If packet is missing, we can just resend with its up-to-date data, include up-to-date data, instead of resending the old value. But the problem is that its partial updates might break the game logic. For example, you might receive a component that stores, you might have a component that stores some entity. And after an update, this entity, it may point to a new entity. But the client might not receive this entity yet. And that's the issue, because when you receive such update, your game may just crash because you have a non-existing entity or entity without the components that you didn't receive yet. So the proper solution for this would be utilizing multiple channels. And that's exactly what we do. The idea is quite simple, actually. So basically, we send everything except mutations over a reliable channel. Things like insertions, spawns, removals can be out of date. Even if you spawn and despawn an entity, your client might want to run some logic related to it, like, for example, count the number of deaths, for example. And for mutations, we use unreliable channel and always send the latest data. And but that's not it. Not only it. we also do some specialized splitting. For reliable channel, we don't do anything special. We just use a single message, pack everything in a single message because we don't want to lose. We don't want to apply the update partially. It would be weird if you replicate half of the world. That doesn't make much sense. But mutations are split into package size messages. So we try to pack them efficiently. And this allows us to apply mutations partially because they don't break the game logic. And to properly deal with partial updates, we assign a required tick for each mutation. So mutation messages rely on special tick on which they happened on server. For example, if there was a recent, so basically we just look for the latest insertion, removal, spawn, or despawn, and include tick when that happened to the mutation message. And mutation messages on client are both buffered until the update with this message is received. This way, we basically preserve archetypes. So this way, you can receive an update. You can receive a mutation for non-existing that references a non-existing entity. So we preserve on the server state on archetypal level, but we also don't resend outdated information over the update channel. Moving next, I also mentioned that modern game engines have special mechanism called RPCs. It's because you can just have only replication from server. You need some way of client to tell what clients wants to do, because we're not just watching a movie, we're playing a game. We want to interact with the server, and since replication happens only from server to client, we want some way for client to interact with the server. So basically, we have this remote events from client events that are sent from client to server called client events. And the API is quite simple. You just register a client event like this, and you just send an event as usual, like this. I'm not sure if you can see my cursor. Anyway, on server, you receive the same event, but wrapped into from client structure. What is this from client structure? It's simple wrapper that actually includes information about client entity and contains the event itself. It's because on server, we want to know which client sent which event. This is why we have to use this wrapper for all our events. And we also have server events. They work in a similar way, but when you send the event, you not send just the event directly. You use this special wrapper called to clients, and this where you specify the mode of the sending mode. And on client, you just receive a regular event. It looks like this. This wrapper is actually quite simple. Bevy also recently introduced triggers, and they have a quite similar API, just like in Bevy. Triggers are basically a different way to trigger and react on events. The API just mirrors events in our case. Client triggers look like this, and server triggers look like this. Yeah, and also we have independent events, because internally all events are also buffered, just like updates, until the required tick is applied. Because you don't want to receive an event for that references an entity that you didn't receive yet. But this actually can be disabled. this can be opt out if you want to via special method. Okay. Now, I also mentioned that we can abstract over configurations. We have these 4 configurations. They are pretty common. Listen server, when the server is also a client. Dedicated server, when you just have only server logic client that don't have any authority over the changes, and single player when you just run the game without any networking. There are several approaches to this. Let's take a look real quick. So the classic approach is to separate client and server logic and run both server and client for a listen server. So basically, when the server I mentioned previously that listen server is when the server is also a client, and we just run both client and server for it. Single player is similar, but it's like listen server, but we don't accept any connections from outside. But there is a problem. Running both server and client in the same app would cause an infinite replication loop. It's because server, it's because we use change detection. On server, we detect changes, send it to client, and client applies the changes, which also causes change detection to triggers, and this would cause infinity replication loop even if you don't have any changes. So possible solutions would be to just use two Bevy apps inside the single actual app via separate threads, or two executables. It's quite simple. For example, in Terraria, you can host a game. When you host a game, it just runs a separate dedicated server in the background. But there is also another way, which I usually recommend, and it's on client, run only client and its logic. For dedicated server, you do the same thing. You run only server and its logic. For listen server, you run only server and both logic. And in single player, you don't run client nor server, but run both logic. And to achieve this, user just need to use run conditions. There is run condition called server on single player that is usually applied for systems that require authority. It's systems that usually deal damage, actually applies damage, systems that send server events or receive events from clients. And there are client and server specific systems that are used for miscellaneous things like display connection message, or on server, you may want to display a special menu that allows you to keep connected clients. And that's it, no special conditions needed for other systems. And in Replicon, we made it to just work. So user just need to carefully put run conditions and it will work perfectly. But I see that I actually running out of time, so I maybe not be able to tell how it works actually under the hood. So maybe Stefan, can you tell me? Can I continue, or are we running out of time?
Yeah, you probably have to cut it a little bit short, but if you're not talking about how it works under the hood, that would be kind of a bummer. So please give us an insight.
Okay. Let me continue. Quickly continue then. Okay, so here's what we do. For replication, it's quite simple. We just run send replication on dimension server running condition. It's special run condition we provide. And we receive replication only if client is actually connected. And we don't need to run receive replication when you are a listen server, because you already have all the data in your vault. You don't need to send it, or you don't need to receive it. And when you run single player, you actually don't need to send anything. or receive anything. But I mentioned previously that for single pair, you just don't need to run nor server or client. It should just work. So for replication, it's quite simple. We just internally we just put these two run conditions and it just works. But for event, it triggers it's a little bit trickier, but I think it's quite a nice pattern. Basically, we just internally we just drain the events on client and we just re-emit it as from client locally with a special server entity or server if server or single pair condition returns true. And we do similar thing for client events. We just drain to clients and resend it locally, adjust the year if the server is a recipient of this event. So I previously mentioned that you can run both server and client in a single app, but we actually don't need to do it because we can actually carefully drain and retrigger locally events and triggers locally. And replication actually don't need any special logic for it. That's it. This is why it just works in Replicon, and this is why I think it's quite simple. And then I have a quick a few slides about high-level replication. It's shouldn't take a lot of time. If you can give me a few minutes, Stefan, I can quickly skim through it.
Go ahead.
Okay, great. So how to exchange the data? Let's quickly take a look. So I previously mentioned that client communicates with server only using triggers and events. You can't replicate from client. Replication happens only from server. That's for security purposes. And the server usually replicates the state back. So clients, basically what we do, we client send event. I want to do something, the server sends the information back. But there are a few problems that may be important depending on the game you're making. If you don't replicate every frame, because I mentioned previously, it's expensive. So this introduces slight teleportation when you sync by position. And also, networking doesn't happen instantly. So it introduces some latency. To solve this, you can just interpolate the received state. If you don't care about latency, you can just interpolate the state and it will just work. Another possible approach, if you care about latency, the solution would be just to predict the simulation. But there is another problem. It causes mispredictions because basically when you predict something on the client, you actually run in the future comparing to what server sees. Because you apply the change immediately, and for server, it takes some time to reach. And this could cause things like, for example, player moves to point X, but player 2 actually stuns player 1. And how to deal with this? Well, the solution is simple. Actually, you want to, well, not that simple, but it's solvable. Basically, you receive the state when client receives the state from the server, it applies it, and then resimulates starting from this state and replace all the inputs. There are two strategies about how much you want to predict. And for shooters, you want to predict individual entities, while for physics-based games, you need to predict the whole world. Just because you won't have a correct simulation if you want to do it. In Replicon, we provide an API for it. Basically, we provide client markers that allows you to override how components are written, and this way you can use it to override how components are written. For example, you can write not to the component directly, but instead use a special history component that you utilize in your interpolation or rollback rate, etc. We also provide text information that are also important for prediction. they are optional. You can disable some of this functionality because it's actually more. If you don't care about prediction, it would be a bit more costly to track this information. Because, for example, in order to properly decide, in order to properly know which updates were received, you need to send updates every time, even if you don't have any changes on the server, just send empty messages. But if you don't need prediction on rollback, you don't have to send these messages, and you can save some bandwidth. So we provide customization for it. And the last thing we have, here's what we have right now. Basically, for interpolation, we have a proof of concept crate called Bevy Replicon Snap. It allows you to interpolate your components, state of your components. We have a crate for entire world rollback, but it's in development. You may heard about it if you hang around in networking in Discord, in networking channel in Discord. And for shooter style rollback, we don't have anything. Yes, but that's only for Replicon. There are other crates that provide shooter style rollback. They are just not integrated with Replicon, such as Lightyear or Naya. And that's it. In the end, I just left a few useful links that might be, if you are interested in networking in general, you might want to check them out. That's it. Sorry, I really tried to squeeze a lot of information into 25-minute talk, but it's
all good. Hennadii,
really
thank you so
hard.
much. That was really a lot of interesting content. So I would cut the Q&A now to the two mostly rated questions, and then put the rest for the panel at the end. So did you benchmark the limits of the system, and what limits did you run into?
Honestly, I never benchmarked the limits. We have benchmarks. I always measure the performance, but I believe that replication will rarely be a bottleneck. Most of the time, it will be physics and things like rendering. You rarely run into performance issues with replication, at least with Replicon. It takes a few nanoseconds to replicate this stuff. We tried so hard to make it as optimal as possible.
Cool. And the second one, you mentioned Bevy Lightyear. So what would be the quick difference between the two? What can you do that Lightyear can't, and the other way around?
Well, Lightyear is like transport messaging crate plus Bevy Replicon plus high-level rollback crate, and plus possible lag compensation crate. So Lightyear provides everything in a single package. Lightyear also have the mentioned high-level functionality like client-side prediction and interpolation. We don't have a really mature crate for Replicon yet. So if you care about prediction, I would highly advise to check Lightyear. But if you don't care about prediction for your game, I would recommend to check Bevy Replicon, because it might be more performant. But at least based on what I saw. So Lightyear more focused on features, while Bevy Replicon is more focused on performance and extensibility. So you can extend on things on top of it. I also mentioned previously that there are two possible ways of how to roll back the several individual entities and the whole world. And Lightyear implements the individual entities approach. So if you you aren't building a physics-based game, it should be a good fit for you.
Interesting. Okay, cool. Hennadii, thank you so much. That was super interesting. Big hand from chat, please, for this presentation. I'm super curious about the networking crates that we have in Bevy myself. So this was super interesting to me personally as well. Thank you so much for being here, and see you at the panel conversation at the end again.
Thanks.
Okay, So now we are going to our second speaker tonight. And I'm super grateful for Pete to wake up early in the morning for this. And he's going to be live from Australia. Give a big hand to Pete.
Thanks,
Hey
Stefan.
there.
Hello. Hi, everyone.
Let me get your slides up here too. Okay, so you should be ready to go. The stage is yours. Thanks, Pete.
Awesome. Hi, everyone. Yeah, I'm Pete, or Mr. Shanty online. This is Intermediate Representations for Reactive Structures, which is a title that, after some thought, I thought that maybe that's not totally clear. I had another go at the title, which is it's cool to share tools, which is also not super clear, but I don't know, maybe somewhere in the middle it's starting to make a little bit of sense. Anyway, yeah, so I'm going to talk about two crates that I've been exploring, two areas that I've been exploring. And particularly what I'm interested in is how can different ecosystems empower each other, by sharing tools. And it's kind of space that I've been looking into. Okay, so the reason why I'm using this term intermediate representation is I'm using it a little bit loosely, but it's just for that idea that, for example, if we're talking about a file format like GLTF, right? It's like it doesn't really matter who's authoring it. The output's going to be consistent, right? But when we're talking about an IR, you can actually have completely separate ecosystems. So this could be, for example, web development, a web development workflow. That could be a game development workflow. That could be like graphics workflow. That could be robotics. They could be completely separate, but they can still share the same tools. So that's kind of the reason why I've landed on this, the usage of the term IR. There's a couple of characteristics to what they call a good IR. First of all, it's got to be expressive. So, for example, let's say if this was a web dev workflow, it's important that the IR doesn't limit what that workflow is trying to do. It has to have full capabilities, and so yeah, so it's important for them to be expressive, and it's also important for them to be independent. So, for example, if this one's outputting HTML, that one's outputting like I don't know, BSN or something like that. The one's not forcing the other to be in its format or in its like ecosystem, right? They've got to be able to remain sort of pure and in their own space. Of course, the most famous and probably one of the most celebrated forms of an IR is LLVM. That's very low level. That's kind of like where we can all agree what a function is, and we can all agree what variables are. And so whether we're writing a Rust program or doing a SQL query, suddenly the implementers of those libraries or those languages don't have to worry about reinventing the wheel. We can all kind of share tools and get massive gains from that. I'm gonna be talking on a sort of higher level on the application layer rather than the language layer. Okay. So this is in robotics or electronics. Blinky is like the hello world. It's sort of been around, like you could say, since the 80s, since these sort of hobbyist electronics movements. It's very popular, and I guess something that I've been very interested in is what's the 2025 version. And like Blinky's great for learning hobbyist electronics, but now with all these new capabilities that we have, is there a new kind of hello world that we could be looking into? And for me, this is probably the best representation I can think of.
What is my purpose?
You pass butter.
Oh my god.
Yeah, welcome to the club, pal.
Right. So there's the butter passing robot. So like it's a little bit funny, but like what Rick's doing there is like he's just at breakfast. He's got some idea. Oh, I need the butters all the way over there. I'm just going to whip up a little robot. It's going to go and get me the butter, right? It's kind of like this, like sci-fi fun idea. But you think about it, like in 2025, it's like, well, I don't know, maybe that's possible. Like if we got a few things right, maybe that kind of thing, that kind of expressiveness, and the capabilities, what we could have, maybe that's within reach. But there's one of one of the other things that strikes me about that kind of example is it's very multidisciplinary, right? You've got like it's got like, you know, hard robotics. It's got like things like, you know, computer vision, all that sort of thing. It's got the hobbyist element where it's actually it's not like in a factory. It's actually just doing something fun around the house. It's a character, you know, so you actually have like you know, character design, things like animation. You know, so it's like, if we were serious about how would we create this kind of hello world, this kind of like make this sort of thing easy for like, you know, children to create, we're really going to need all those capabilities, and we're going to need like pretty powerful tooling to be able to get that done. And in particular, something in particular that I think would absolutely be necessary will be simulation, right? So you'd want to be able to make sure that you can do that, test it all out inside, for example, a game engine. Okay, and so the reason why, like, we've all got our reasons why we came to Bevy, why we thought it was such a cool piece of technology. The reason why I got excited about Bevy is, and this is the best way I've been sort of able to sort of describe it, where you've got this idea of, for example, ESP-IDF, that's like your super low level. That's probably what the chip in your fridge, that's probably what was used to develop that, right? So you've got like, that's something that it's really good for developing robotics for professionals, right? Something like Arduino is, okay, professionals use it, and also hobbyists use it, sure. But it's really just for, it's really pretty much for robotics, right? And that kind of limits the breadth of how do you say, like, of ideas of the ecosystem if it's kind of just in that one sort of space. Or for example, Scratch, or I should say Blockly, which Scratch is kind of built on, right? Okay, well, people do robotics on it, people do graphics on it, but we haven't seen that kind of depth, that kind of professional usage of that kind of software. And so for me, what strikes me about Bevy is that it runs on a tiny ESP32. It runs on these tiny microcontrollers, and we're also, you know, we're also got like this massive ecosystem of a game engine. And so yeah, so that's why I'm excited about Bevy, and I'm kind of exploring Bevy as a space, but beyond graphics. And this kind of led me to Beat Flow. So I describe this as a control flow library. Really, it's being used for, you know, things like behavior trees, like, you know, game AI. But the reason why I call it a control flow library is at its core, what it really does is, you know, you got a node, you run it, and then, you know, it's going to run a child node or select which child node to run. That one's going to run. The sort of the core of it is what you could call like a request response observers. You could think of it, for example, a behavior tree is like a parent asking a child for, you know, a run result, right? Did you succeed or did you fail? And maybe that'll return immediately, maybe it'll take some time. But for me, the important part of this library is that it's using Bevy scene, right? It's just, you know, it's just entities, which if you thought through how, for example, visual programming language would work in Bevy, like you kind of imagine that, you know, all those nodes would be, you know, entities, right? And that's a kind of cool part of what you can do with Bevy. Yeah, so it's multi-paradigm. Like all we're talking about is control flow, right? So you can create kind of anything you want on top of that. It doesn't have a blackboard. It's just using the Bevy world. So you know, being able to create all kinds of paradigms. The only one that I've gotten really stuck on is like this kind of GOP or HTN. That's kind of this idea where you have like a hypothetical world where you say like, okay, well, if I were to do this, then what would the next world state be, and what would the score be, or like how beneficial would it be for me to do that? And so I haven't yet found a clean way of sort of replicating the world in that way. But yeah, who knows? Just the way that is at the moment. Where are we at? Okay. All right. Yeah, some examples. So let's see if I. Oh, whoops. Sorry. Oh, okay. What have I done? Let's try that again. So this one is what you call like a sentence similarity. It's kind of like very basic, very basic LLM. It can run on the CPU. It runs in the browser, no problem. And what it's able to do is, like, let's say you give it a bunch of targets. So here it's got like a piece of cheese, a coin, a sword, and a potion. And you can give it things like, for example, I've been injured, and it'll be like, oh, okay, well, I'll go to the potion, right? You sort of give it like it's able to score kind of like utility AI, but using sentences to work out, I want to be rich. Oh, I'll go get you a coin, stuff like that. So these are all, just as a reminder, these are all my attempts to get towards that butter passing robot. Here we also have reinforcement learning. This is the frozen lake, is a little bit like the hello world of reinforcement learning. It's a very famous example for RL. And so you wouldn't actually do training like this. You just do that for debugging. If you're actually training, you probably wouldn't want to render every frame. It just takes a lot longer that way, but it does look a bit fun. This one's just an exploration of like again, because if we're talking about these sort of robotic characters, you also need this expressiveness. And for me, it's really important that these things are really cheap, that like it is for hobbyists. So, exploring, for example, if you were to have a phone on one of those, like, robotic arms, how would that work? Some of those animations. And here it is just running on a little ESP32. So that's just doing the Bevy on a little microcontroller. All right, just give me a moment. I'll see if I can get those slides full screen again. All right. Okay. Right. So should be able to. All right, that's that. Okay, on to templating. So this is the second one that I've sort of been exploring. What's a template? A template is where you've got a little bit of data, and you've also got some. Let's say you've got like some structure. What I'd call a reactive structure. You're co-locating your code and your structure. So this is actually this is the same as this is a Leptos what do you call it, parser, the same parser that Leptos uses called RSTML, and so just exploring like if you think about it, like maybe I've got these slides out of order, but exploring what is a template made of, and how can we find some tools that would be able to share. So first of all, just to explain exactly what's going on here, is if you sort of squint at what these templates are, is it's like half structure and half code, right? Whether you're talking about HTML or BSN or anything like that, you're going to have some of it's going to be sort of fixed structure, which really could be like in an asset file, but we don't want to do that because then you've got two different files. That's quite difficult to work with. You want to co-locate it, but some of it's static, right? And whether you're talking about web pages or scenes or behavior, like in Beat Flow, you still sort of got this. You still got this this pattern. It's all kind of the same sort of stuff, right? And so this is an area that I'm very just most recently just been exploring. Are there opportunities for shared tooling? And so far I've been looking into hot reloading. So this is the kind of hot reloading that you'll see in Leptos or in what's the other one? Yeah, so yeah, I can't remember the other one. There's Dioxys. Dioxys also has this kind of hot reloading, but like all the frameworks like everyone's got to create their own hot reloader, right? And of course, Bevy's going to have something similar to this as well. And so like I'm wondering, like, is there an opportunity where we could actually, I don't know, Leptos and Bevy could work together and sort of share tools. So what I've been able to do here is kind of have a process that's looking at the file and saying, okay, well, I know the file changed. Well, when the file changed, was it the going back to that slide before, like, was it the code part or was it the structure part? Because if it was just these static parts, then we don't actually need to recompile. We should be able to just extract that, right? So that's what that's doing, So then you're talking about, what, 2.6 milliseconds to re-render that. And again, like these examples on their own, maybe they're not terribly interesting, but it's the same technology. So for example, this is it, same thing being used for Bevy, and yeah, so I'm not suggesting that we use HTML markup for Bevy scenes. What I'm suggesting is that we use the same underlying technology for Bevy scenes and for example, Leptos web pages, and maybe use the same markup. Like for example, sorry, here we go. Going back to this slide, like I don't know, like maybe if you're making a website with just a little bit of scene, maybe you do want to use a HTML markup, or maybe if you're using a game with just a little bit of website, maybe you want to use a BSN markup. I don't know, but I feel like there's opportunities for collaboration, and that's what I'm exploring with Beta RSX. All right, I think that's everything. Oh yeah. Okay, sharing is caring. So, of course, the JavaScript ecosystem is massive, right? They got so many people. We don't have so many people, but we've got very creative people in the Rust ecosystem. Our web dev and our game dev communities, they're small, but they're creative, and our language is really powerful. Rust is a really powerful language. I feel like there's a lot of opportunity for us to collaborate and have these ideas of intermediate representations, where even if we're completely separate ecosystems, whether it's graphics and robotics or web and game, like I feel like there might be some opportunity for collaboration. Thanks.
Hey Pete, thanks so much. That was interesting. So my first personal question is, which part of Bevy crates did you use in your robot?
Which Bevy crates?
Yeah, is there any parts of Bevy running on this robot?
Yeah, that one is purely Bevy ECS, I think. I think that original
nice.
one actually just used like Bevy _ ECS as a dependency. Although yeah, in the future I'd be more interested in for example, looking into something like if Replicon could run on a robot, that would be awesome. Something like that would be very cool. So could
nice.
be reflect as well would be useful.
So you would make the different players in a Replicon session be different actual robots.
Right. Yeah.
Interesting. Okay. There's only one question left, so let me quickly go to that one. Do you know if reactivity in Bevy will use a similar approach, like what you did with RSX? Are you following that?
It's a good question. I don't know. Like the way that the Bevy community works, I feel like there's going to be 20 different ways that reactivity is going to work in Bevy. The way that works, the way that particular example works. Where is it? That one? Next one. The way that works, that's just using observers. So that on click is literally just an observer with an inferred trigger type. So observers get us pretty far with reactivity. I don't know. I don't know. It'd be really interesting to see how it goes with BSN and once we start getting really serious about creating UIs. Yeah.
So that's what's used inside of this Bevy signal type that I see there.
Yeah. It's like
observers?
observers dressed up as signals or like with a signal like API. But yeah, it's just an observer. Yeah.
Interesting. Super cool. I wish I have ever time to build a robot as well and run some Bevy code on it. That's amazing.
Yeah.
Okay. Pete, thank you so much. I'm going to put up Shatur again, and we can go through the rest of the questions together. Hey, welcome back.
Hi.
So, Pete, feel free to jump in as well with your own questions and answers as well. I think some of those questions are a little bit high level, so let's see what we got here. What's the highest voted one? If I replicate something using an asset, will that just work out of the box on other clients? Like will it load an asset on a client that didn't run that code initially and just wants to replicate that entity?
Well, right now we don't provide any built-in functionality to streaming assets like it's done in some engines. Like I think Unreal does provide this functionality, but you can just send the asset over the network and just send the name of this asset, and the client can just load it. The way I usually do it, the way I would do it, and that I might believe just if the asset is known, I would hash it first, and then just have a component with this hash, and then just create a trigger that listens for insertion of this component, and based on the hash, it would load the correct asset.
Okay, so if the asset is in both users or both clients' asset folder, I still need to add some custom logic that will make sure that an asset will be loaded via the asset store first on a client that tries to replicate an entity with that.
Yeah, the simplest approach is to just have a component with a file name. But a hash might be a bit more efficient because you just can replicate the number. It's simpler, it's faster, but a bit harder to set up.
Okay. And from client, I believe that was one of your types that you showed. From client, messages are cool. Can I also make those go via the unreliable channel?
Yes,
I guess
sure.
This the event writer reader system, right?
Yes. So when you register the event, you set the channel. You configure the channel. You can use unreliable, reliable ordered, or just reliable unordered. Yes.
Nice. Okay, so that works on type level then, for a specific event. That's cool. And are the run conditions dynamic if I'm hosting a game and then join a game later just as a client? Oh, I guess is that statically compiled into it, or is it?
Kind of depends on the game. Well, if your game can both simultaneously be as a client and as a server, then you might want to just do it at runtime. But if you do dedicated server, you probably just want to strip out the logic via either conditional compilation or by separating by using a different crate for dedicated server logic and for client logic. But run conditions are for runtime checks. It's for cases where you want to support server hosting and client logic in the very same binary.
Okay, gotcha. Yeah. So they will not automatically be like filtered out or compiled out if I, for example, have some feature flag for, hey, I'm server only, I'm client only.
No, they won't be. if you want to do that, you want to just compile out the systems themselves.
Yeah.
Yeah, conditional
Gotcha.
compilation.
We are already approaching the last question for you, Hennadii. So does Replicon support all features that you needed for your own game project that you mentioned in your presentation?
Yes. My game doesn't need any prediction or rollback. It's a very slow-paced game. So this is also one of the reasons why I didn't include client-side prediction into the core of the library initially. But in the end, I think it's turns out quite okay. I hope that in the future we will see some libraries that implement client-side prediction on top of it.
Yeah,
there are
more modular.
Yes. I would like to add some more features. I think I will add some more features during development. For example, I think per component visibility would be nice to have. A quite requested feature, and we don't support it yet. We can the visibility right now is configured on entity level, unfortunately. But I want to add more granularity.
Okay, interesting. So in your game, how many clients have you had in one single session that you tested?
Well, I tested it currently only locally, so I just used server, one listen server and one pure client. That worked pretty okay, but of course it's just local testing. But my game is not pure online. It's mainly a single-player game with online functionality that is optional. It's more like you can play with friends, for example. So I don't expect a lot of players connecting to a server. But I tried quite hard to make the Replicon itself optimized as as possible. We have a lot of tiny bit optimizations that I just couldn't include into the presentation. It would take a lot of time to. It would be nice to talk about them, but I just have strict time limit, unfortunately.
Well, you can always come back, I have one for you, Pete. This is now we are done with the questions from Live Ask in chat. If anyone wants to ask something else, please go ahead. I'm still going to be looking at it. But one thing that I was curious about the crates that you mentioned. Do you know if they're used in any other project than your own?
Yes. Speak is using Bevy. Beatflow. Yeah. So yeah, Beatflow is used in a couple of projects. Yeah.
Okay, so you were also extending it already in like conversation with users and like outside of what you needed for your own desires there.
Right. Yeah. Hoping to make it a bit more accessible. The current version doesn't really have any documentation, but we've got deny missing docs for beat 0.0.5. So yeah, so stay tuned for that.
Yeah. Okay. Same question for you, Hennadii. Is what projects are you aware of that use Replicon?
I have a bunch of people asking questions, and some of them showcased their projects. I know for sure that it's used by NiceVoid, the one I mentioned previously, the guy who working on a Rocket League style of prediction. It's for an RPG game. I also know a guy who works on a tower defense. And I don't know if it's used. I didn't saw other projects. I mean, videos of other projects, but I know that there are some people who use Replicon for their project. I just don't know any information about their projects yet, unfortunately.
Yeah.
Most of the time,
you get a feeling of the issues that people report, right? Or reaching out on Discord.
Yes. I have a feeling that most of people actually use just pure Renet and implement everything on top of it. Most of the time, just not because our current ecosystem is like bad or something, like and Replicon is a nice crates, but for some reason people with Bevy like to roll their own thing.
Yeah,
so I know quite a,
Yeah, wasn't invented here syndrome. Yeah.
Yeah, I saw quite many projects in project section in Bevy Discord that use pure Renet.
Yeah. And for both of you, is everything that you showed us compatible with WebAssembly as well, in case people want to use it for a project for that?
Yes, Bevy Replicon can be used in browser, but you need a backend that is compatible. Replicon itself uses only Bevy and a few dependencies like Postcard. I also think that it might be compatible with, it might be easy to make it even compatible with NoSTD, because we don't use any crates that require STD. It can be disabled in Postcard, Bevy itself, since recently, and a few others I checked. Like we used ordered multimap. I saw it also have STD features. We just don't have a backend that have an OSTD yet.
How about you, Pete?
Yeah, definitely. WASM and robots and little microcontrollers. So that's definitely a real priority. Make sure that.
So that's basically everything. Yeah. Did you try it on a toaster yet?
Try it on a toaster. That's right.
There's actually a question for you, Pete, in chat. So have you tried the GPU accelerated reasoning LLMs to power game behaviors, or just smaller CPU models?
That's a great question. That's where I'm at right now. Actually, is I'm working out how particularly working out how planning works with these LLMs. You know, they start to do these kind of let's think this through step by step, that sort of process. Sort of formalizing that, seeing how that would work is definitely a point of interest.
But then you would use the existing technology that's not like that's outside of Rust or do you use Rust specific GPU supporting LLMs?
Yeah. So Hugging Face has a great crate called Candle, which is kind of like the Rust version of PyTorch that allows us to do a lot of that stuff. Actually do all of that. In terms of inference, in terms of like just running LLMs, we pretty much got everything we need.
Okay. So that's what you're using too.
Yeah. I'm using that one. The reason why they built it was because they don't want to run Python in a server, for inference, for just for running these models. It's like, well, Rust is actually a really, really good option for that.
Yeah. Okay. Fair enough.
I wonder how much Rust is faster when you use it over PyTorch. Does it provide any performance differences, or Python just uses C under the hood actually?
I think for the actual running of the models, I think that the performance would be similar. The pain point, that the way I understood the pain point is in a serverless environment, is spinning up a Python environment versus just binary.
Makes sense. Yeah,
I think in LLM speech, the majority of the work, like it's going to be negligible what you save by controlling it from the outside with Python versus Rust. I think the majority of work happens in these GPU intensive, highly parallelized tasks, right? Okay. Super interesting. Last question from my side. We are approaching the next big Bevy release. What are you guys most excited about for Bevy 16? Hennadii, where you start?
I personally most excited about relations, of course, because in my game I have a lot of things like, for example, family, an entity that represents a family, and each family member is also an entity, and I have a hard time synchronizing all these relations by hand. So one-to-many relations is just like reduces a lot of code for me. Same thing with actions, because actions for characters in my game are also entities, and I have a list of actions, and I have to synchronize them also as well manually. Sometimes I'm even being too lazy, just use parent-children relations, but they are not designed for that. Actually.
Yeah.
So looking forward to this feature.
Cool. Pete, how about you?
Yeah. One to many's gonna help some things. It's gonna clean up a few parts of the Beat code base, but what I'm really excited for is many to many. That's gonna really change things. Just in terms of how Beat flow works, it's gonna make a few things like a lot easier to sort of work with. Yeah.
Do you know if that's still on the roadmap for 16?
I'm not sure about 16. Yeah.
Okay.
But yeah, maybe a bit later.
Yeah. Okay, guys, this was awesome. Thank you so much for taking the time preparing a presentation like that. Took away a lot from that, and yeah, I'm just very thankful for getting up late in your case, Shatur, and getting up early in your case, Pete. So very appreciated. So big hand from chat for both of you. And hopefully, Hennadii, you get another chance to talk about the rest of Replicon next time.
Yeah, maybe.
Okay, this was it again. This was the 9th meetup. Thanks for joining. Thanks for sticking around and for joining the conversation on the live Q&A platform. If you're curious about upcoming meetups, be sure to subscribe to the YouTube channel. Everything will be streamed there, and the recordings will be coming up eventually over the next week, probably. And of course, join the Meetup group itself. Don't miss another appointment. And if you're curious what Rust Unit is doing, then please check out rustunit.com. And thank you so much for being here.